This is Ham College, episode 24 for December 31st, 2016. Ham College is brought to you by ICOM. Holiday season is here, and ICOM's got the gifts on your Santa list. And by hamstudy.org, a great place to study for your next ham exam. Good evening, everyone. Thanks for joining us for another episode of Ham College. I'm George.
I'm Tommy.
Actually, I'm Professor Thomas.
And I'm Dean Martin.
This is the last time we were going to be able to do it this year.
Yeah, it is.
So glad you could be with us tonight. This is being recorded on Friday night, December 23rd of 2016. We're going to, be back in the technician exam tonight. We'll be moving on to antennas here after we get a few other questions out of the way.
Oh, yeah.
You know, anytime we're shooting live, we've got a chat room going on, AmateurLogic.TV/chat.
Yeah, come join us over there. There's always a lot of hijinks going on, a lot of interaction when we're going through the question pool. And, it's just a kind of fun place to hang out.
It is. And, we look at it throughout the show. Particularly to see what everybody is saying is a correct answer before we post it up there, so we kind of know if we're in the ballpark on some of our guesses there. But a good group of folks in there. Come join them. Come join us. Tommy, what did we talk about on the last episode? Do you remember?
I remember vaguely. We talked about dB or decibels.
Mm-hmm. Yep. There was a typo, and I'm not sure how this one got in there, but we were talking about decibels and being base 10 numbers, and then we showed this right here, and that's not actually correct, is it?
No, that's not correct.
Yeah, it's wrong.
Yeah, that's what it should be.
That's what it should be, is, like 10 equals 10 to the 1th. I'm not sure how you say that. 100 is 10 to the second.
First power.
Powers
third
of 10.
power.
Yeah.
Or squared and cubed.
So just wanted to clear that up.
We never claimed to be mathematicians.
We didn't. And as best I can remember, nobody's ever accused us of it either.
No, nobody's ever. So, I've been accused of a lot of things, but that's not one of them.
No.
So.
Well,
so anyway, sorry about that.
Yeah, sorry about that, but
happens.
There's your correction right there. Anything else we want to cover before we get to rolling tonight, Tommy?
We should probably mention the format changes that are coming. We mentioned it on Amateur Logic, but some of these people may not be Amateur Logic watchers. They should be, but they may not be. So starting the first of the year, we're going to scale back the number of RSS feeds and file formats that we're putting out each month. We're going to have the HD or high definition version, the H.264 version, and the MP3 audio alone version.
And that shouldn't really affect anybody. You should still be able to watch the show just like always, because most every player out there will support those formats. The only issue may be if you're subscribing to one of the Windows Media RSS feeds, you'll want to update that.
Yeah, and I'm going to try to redirect that. I'm not sure if I'll be successful or not, but I think I can create a symbolic link to it and make it semi-seamless. Yeah. So I'll have to play around with that. But if you don't get an update, you may want to go subscribe to another feed.
Yeah, Mike, no more Super 8. Sorry about that.
No more,
Or VHS either.
You just can't hardly get film anymore.
No. We dropped beta a long time ago. But, we're doing some... We've done some software upgrades and stuff that'll allow us to improve the quality a little. You notice we're streaming in HD now. But the quality of the HD files and the H.264 files will be better. They'll be smaller too.
Smaller and better, smaller file size, better quality. So,
faster downloads.
yeah, faster downloads. And you can play those H.264 files. If you're worried about the size, you can play those on, even Raspberry Pi plays it with no problem. So,
Right.
So, it's no problem to use those.
I've got something here I just wanted to get in this year, Tommy. I hadn't discussed this with you, but it's something that, hams and aspiring hams alike should probably need to know about. Electronics is big in ham radio. It's part of your exam questions. And right here, I've got a little document I wanted to go over real quick. This was originally published in the E-Times magazine by Rick Curl, and Jeff Bearden posted it to our Facebook group recently. What it is the 10 Commandments of Electronics. So these may help you.
They won't hurt.
They won't, well,
okay, I'm going to wait till I hear them first.
Number 1.
Beware thee the lightning that lurketh in an undischarged capacitor, lest it cause thee to be bounced on thy buttocks in a most ungainly manner.
That's true.
That is true.
That's a good one.
All right, let's try number 2 here.
Cause thou the switch that supplies large quantities of juice to be opened and thusly tagged, so thy days will be long and fruitful upon this earthly vale of tears.
Means throw the breaker and tag it so nobody can turn it on you.
Yeah, where I work, we have a procedure they call lockout, tag out.
That's it. That's what they're talking about. Number 3.
Proveth unto thyself that all circuits that radiated and upon which thou worketh are grounded, lest they lift thee to high frequency potential and cause thee to radiateth also.
Yeah.
I'm glad you're reading those and not me.
I think it kind of means, be careful around RF radiation or you might be the radiator.
Yeah, be the antenna.
Yep. Yeah, the King James version of these is a little harder, and I'm not even sure they knew what electronics were back when this was written.
Yeah.
But number 4.
Take care that thou useth the proper method when thou takest the measurement of high voltage, in order that thou dost not incinerate both thee and thy meter. For verily, though thou have no account number, and canst be easily replaced, thou meter doth have such a number, and as a consequence, its loss will bringeth much woe unto the supply department.
Don't blow up yourself in your meter while you're measuring high voltage.
Your meter.
Yep. Number 5.
Tarry thy not amongst those who engage in intentional electrical shocks, for they are surely non-believers and are not long for this world.
That's true also.
Yeah, I would say so. Let's see.
Take care that thou tampereth not with interlocks and other safety devices, for this will incur the wrath of thy seniors, and bringeth the fury of the safety officer down upon thy head and shoulders.
This one I like here. This is pretty true too.
Worketh thou not on energized equipment, for if thou dost, thy buddies will surely be purchasing beers for thy widow and consoling her in ways not generally acceptable to thee.
That's not right.
No.
But I guess it could happen.
Number 8.
Verily I say unto thee, never service high voltage equipment alone, for electrical cooking is a slothful process, and thou might sizzle in thy own fat for hours before thy maker sees fit to drag thee unto his fold.
Ooh.
Yeah. Ooh, that's
Be a bad way to go.
Yeah. Number 10.
Trifle thy not with radioactive tubes and substances, lest thou commence to glow in the dark like a lightning bug, and thy wife be frustrated nightly and have no further use for thee, excepting thy wage.
No wages.
And number 10. And I haven't really read over these very well before we started tonight, and I think that's pretty
They're
obvious.
pretty good.
Committeth to thy memory the words of the prophet, which are written in the instruction manuals, which giveth the straight dope, and which guideth thee, that thou might not maketh a mistake.
I think that one means
Read
look
the
in
manual.
the garbage for the manual.
Yeah,
Yep.
that's usually where it is too.
Yep. Anyway,
Those are good.
yeah. What do you say we get on into some questions and answers? Why don't you read the first one tonight here, Tommy?
All right. Which of the following measurements are commonly made using a multimeter? A, SWR and RF power.
B, signal strength and noise.
C, impedance and reactance.
Or D, voltage and resistance. And this one's mine to answer.
Yeah.
Which of the following measurements are commonly made using a multimeter? Well, a multimeter, that's like my Simpson 260, or another term for it is a VOM or a voltohm meter.
Mm-hmm.
So you're not going to measure SWR and RF power with that. You're not going to measure signal strength and noise. It won't measure impedance or reactance. It's voltage and resistance. Do you concur?
Well, since it's a volt and ohm meter, and
That
that's
would
voltage,
Kind of figure, wouldn't it?
yeah.
And they're all saying D over in the chat room. There we go. Nailed
There
it.
you go. You nailed it. You would have missed that one.
If I would have chose the wrong answer, it would have been, yep.
We would have got to hear that buzzer.
Yep. Maybe we can hear it before the night's out. I don't know. We'll just have to
Never
see.
know. It's happened
right.
before.
Well, I've got one for you then. What is probably happening when an ohm meter connected across an unpowered circuit initially indicates a low resistance and then shows increasing resistance with time?
We may hear it this time.
A, the ohm meter is defective.
B, the circuit contains a large capacitor.
C, the circuit contains a large inductor.
Or D, the circuit is a relaxation oscillator. Okay, so I'm going to scratch that one off right now because I don't even know what that is.
There is
So-
such a thing.
Yeah, but I don't know what it is, so I'm not going to pick
Okay.
it. Okay. The ohm meter is defective. The ohm meter is connected across an unpowered circuit. Unpowered.
Mm-hmm.
Initially indicates a low resistance and then shows increasing resistance with time. The ohm meter is defective. I don't think that's right. Circuit contains a large capacitor. Circuit contains a large inductor. I'm going to guess on this one because I really don't know the answer.
Okay.
But I think it's going to be. I'm just going to guess it's going to be B, and I'm thinking the ohm meter. There's a small amount of electricity in there. I'm just wondering. I'm guessing it's something to do with the capacitor and the voltage
All right.
from the ohm meter. I honestly don't know though. We may hear the buzzer here.
So you're saying it's B.
I think it's B. I'm just guessing though. I really don't know. I hope you can clear it up for us when we're done.
Well, there you go. You lucked out on that one.
By the skin of my teeth. But why is that the answer then?
Why is that the answer? And you know, I wish I would have brought an ohm meter back here so we could look at it. If you take an ohm meter, let's say an analog one that's got a meter on it, when you touch it across a capacitor, that capacitor, the voltage coming out of those probes will try to charge that capacitor
Okay,
up.
that's what I was thinking. That's
Yeah.
kind of what I was saying, but I may not have said it. just
So
like that.
it'll draw as much current as it can out of it for a short period of time. Once the capacitor's charged, then it drops off, drawing that current, and the resistance increases.
Okay.
So that was probably our best chance to hear the buzzer tonight, since you didn't know the answer. I was thinking you knew the answer to that one, but
No, I just kind of reasoned now that that's
Yeah.
might have been that principle you're talking about would be the answer, but I wasn't totally positive.
that's what they were all saying over in the chat room. So
I left my relaxation oscillator at the house, so I couldn't really
Yeah.
try that.
I really should bring a meter back here and show that one, because then it would stick in folks' minds that.
Yeah, that'd be good.
I'll tell you what. Why don't I do that?
Okay.
You can see there's a pointer here on this meter. If I take the two leads, short them together, you can see that pointer there moving.
Yep.
That's toward 0 ohms. That's toward infinity. Here's an
Beyond.
electrolytic capacitor right here.
Okay.
And you can see there's 2 leads on it. Now, if you'll hold that capacitor, when I touch the 2 probes of the meter on the 2 leads here, watch what happens down here on the meter.
Okay. There it went. It jumped up and then it went down.
All right. Now, if I do it again, you see it won't
It's
do
already
anything.
charged up.
But if I reverse the leads and do it,
Okay.
so the meter's not defective, and that's how it works.
Which of the following precautions should be taken when measuring circuit resistance with an ohm meter? A. Ensure that the applied voltages are correct.
B. Ensure that the circuit is not powered.
C. Ensure that the circuit is grounded.
Or D. Ensure that the circuit is operating at the correct frequency. Okay, when I'm using an ohm meter, it's putting a little DC voltage out of those 2 leads. And so there's already a voltage there. That means I want to be sure that the circuit I'm working on is not powered. So that's going to be the one. Let's go over the others.
Okay.
Ensure that the applied voltages are correct. No, you don't want any voltages on the circuit when you're going to measure it with an ohm meter, because if you cannot measure the resistance of, say, an AC wall outlet. Someone tried to do that in school, and
Did they sizzle in their own
they let
fat?
every bit of the smoke. No, they didn't sizzle in their own fat. And they weren't married yet, so that wasn't an issue either. So, but it smoked their meter.
Oh, yeah.
Okay, so no applied voltages on a circuit if you're going to be measuring resistance. C, ensure the circuit is grounded. No, the circuit may be grounded, it may not be grounded, but that's not a requirement for measuring resistance.
Right.
Ensure that the circuit is operating at the correct frequency. Your ohm meter is going to measure resistance using a DC voltage. Resistance is a DC measurement. It's not an AC measurement, so there is no correct frequency.
It's futile.
You could say that. So it's B, ensure that the circuit is not powered, and everybody over in the chat room was saying that. I bet you would have got that.
Oh, yeah, I knew that one.
So let's see. There we go. Ensure the circuit is not powered.
Yeah, I'll let the smoke out of a couple of meters past, too.
Yeah, it's easy to do. It's easy to do. So always, before you go to measure a voltage with your meter, just take a quick look at it. See where you got it set, because,
Yeah. Or you'll be buying a new meter.
you'll be buying a new meter. I think it said something about that in the 10 Commandments. There.
It did. Or you'll be going to the, what do they call it?
You are not easily
Supply
replaced, but the
department.
meter, is.
Yeah.
But it causes problems for the supply department.
Yeah.
So.
See, those are words to live by.
Okay.
If you can understand them.
Yeah. Well, I got one here for you.
Okay.
Which of the following might damage a multimeter? A, measuring a voltage too small for the chosen scale.
B, leaving the meter in the milliamps position overnight.
C, attempting to measure voltage when using the resistance setting.
D, not allowing it to warm up properly. Well, I know it's not D because I never put my multimeter through a warm-up cycle.
But and you never you never have. There's such a thing as a vacuum tube voltmeter, a voltmeter that has a vacuum tube in it.
Oh, yeah?
Yep.
I've never used one of them.
No, and you're not likely to either, but I can't remember if they had to warm up or not. But anyway, I agree with you. Not allowing it to warm up is
Okay, so
throw
let's
that one out.
measuring the voltage too small for the chosen scale. That's not going to damage it. You're just not going to get a reading or a reading in the scale that you can actually see.
Yeah.
Leaving the meter in the milliamps position overnight, that's totally nonsensical. That doesn't make any difference. C, attempting to measure voltage when using the resistance setting. And I know that's a problem because I've been there and done that.
We just talked about that, didn't we?
Yep. And I confessed on the last question, too. It's true confessions tonight.
I guess so. Yep. You cannot measure the resistance of a voltage source. So attempting to measure voltage when using the resistance setting, yeah, that's going to blow your meter smooth up.
Yep.
And everyone over in the chat room was right on that one, too. So you got one more for me?
Sure do. Which of the following types of solder is best for radio and electronics use? A, acid core solder.
B, silver solder.
C, rosin core solder.
Or D, aluminum solder. And this one, if you've ever listened to me talking about soldering before, then you'll know the answer to this one. And this should have been one of the 10 Commandments.
You should have.
You'll know the answer to this one. Well, first, aluminum solder. You've probably never seen aluminum solder, although there is such a thing.
I think I've probably seen some. I think they sent me some to work by mistake one time.
Yeah. It's pretty rare, but no, we're not going to solder aluminum. I have actually soldered aluminum before, and it was a very difficult and tedious process and took a special technique. Do you remember that?
I've got some rods that you can do aluminum with a propane torch.
Yeah.
I don't know if you'd call that aluminum solder.
Yeah. Or aluminum brazing. I don't know what you would call that. But you can do it with a soldering iron and much gnashing of teeth. A lot of time and some motor oil. But, yeah. Yeah. But anyway, no, it's not aluminum. It's definitely not a acid core solder because acid core, while that solder is going to stick pretty quick, it's also going to be corrosive and destroy your components or your wire over time. So
yeah, so enjoy whatever you're building.
Yep.
Right away.
B, silver solder.
I've used pounds and pounds and pounds of that stuff in the past.
And there actually is, you could use some silver solder if it's a solid silver solder along with some rosin flux, but you typically wouldn't, for doing electronics or radio and electronics.
I used it for installing air conditioners.
Yeah. I've used it for making, making antenna parts before where you needed something pretty strong. But it's going to be C, rosin core solder, and everyone, I know everyone got that over in the chat room because that's just what we use. Rosin core is really not corrosive. Mm-hmm. It works good. There's other kind of cores you can get too. There's no clean fluxes. There's organic fluxes and stuff suited for electronics. But rosin core is the most popular type.
Yeah.
So if you go with rosin core, you really can't go wrong. There you go. C. Well, I have one more here talking about soldering.
Okay.
And I'll ask you this one. What is the characteristic appearance of a cold solder joint? A, dark black spots.
B, a bright or shiny surface.
C, a grainy or dull surface.
Or D, a greenish tint. Okay, it's not going to be D. Green would be some kind of a tarnish type thing.
Or corrosion, possibly, yeah.
Dark black spots, that's not right. I don't know what would cause the dark black spots. Maybe if something got too hot, maybe. Bright or shiny surface, that sounds desirable. C, a grainy or dull surface. That's going to be indicative of the solder not being hot enough to flow. It's just kind of gotten slightly liquefied, I think, and then so that's got to be the answer.
Yeah.
A grainy, dull surface, C.
That's what everyone's saying over in the chat room. C, a grainy or dull surface. That is characteristic of a cold solder joint. Yeah. You get the solder just hot enough that it melted, but it just wouldn't flow.
Yeah, it almost
Right.
looks like mush.
Yep. Now, one thing I'll point out is on some of these newer lead-free solders, some of them will have a little bit of that kind of appearance. You would think it
really?
may be a solder joint, but actually, is that a lead-free solder, which I try to stay away from.
Oh, that's what Mike's saying in the chat room.
Mm-hmm.
We challenge anyone to get a shiny solder joint with that stuff.
Yep. All right, Tommy.
Moving right along.
Moving right along, we're going to come back in a minute, and we're going to switch topics here.
Okay. You need to load the stuff off a floppy disk here?
Yeah, I need to load up off that floppy there. So while I'm doing that, why don't we get a message from one of our fine sponsors here.
All right.
'Tis the season. The holidays are here. Surprise your favorite ham this season with the gift that's on their Santa list. The holidays are just around the corner, and ICOM has an array of radios to fill your stockings and place under the tree. Just arrived for the holidays, the ID51A Plus 2 provides new models for extended D-Star coverage. Available in 5 colors, the ID51A Plus 2 is the perfect stocking stuffer. Terminal and access mode, send and receive text messages and pictures, DV fast data mode, and easy FM repeater settings. Ideas for the contest are on the go? Try the IC7300. It's a high-performance, innovative HF transceiver with a compact design. The real fun starts here. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. Push performance to the pinnacle with the IC7600. Following in the footsteps of ICOM's flagship radio, the IC7600 has an intuitive operation and the latest DSP technologies. Digital IF filter, dual DSP, 5.8-inch ultra-wide TFT display, and high-resolution real-time spectrum scope. Visit ICOMAmerica.com/amateur for more information on all the great ICOM radios.
So what Santa Claus bringing you this Christmas, Tommy? Any idea?
I have no idea.
I
haven't been that good. So
you hadn't.
no,
Well,
so I'm just gonna go ahead and confess right now.
I'm going to tell you, he's going to bring somebody a new ICOM hat and an ICOM T-shirt, and I think you just
He
happen
sure
to
is.
have a floor model here
I sure do.
that we can look at.
Right here. Nice ICOM ball cap and
Yep.
a ICOM Ham Crew T-shirt.
Yep.
You don't get the Christmas tree though.
No, you don't get the Christmas tree.
You look just as good going as you do coming.
You can't put it on backwards. It's reversible. So,
So nice, just nice T-shirts.
Yeah.
Good heavy.
they are heavy. So if you want a chance to win that, it's very simple. Just send us an email to hamcollege@AmateurLogic.TV. You don't need to be a ham. All you need to be is a Ham College viewer. Just drop us an email. You can say hi. Give us your name or some way to contact you. So when we draw your name, then we'll know who to send it to.
Yeah. It's got a real good chance. So there's nothing to lose.
And you know, Tommy, we had
No
a little-
obligation, and we don't give your emails out.
No,
to,
we don't.
to anybody.
So, yeah, keep that hat handy there just a second. Our winner for last month's hat is Don KB2YSI. Don said, thank you. These arrived while I was out of town for work, but they look great in the company of my dad's, who's a silent key now, his ICOM AT radios under the Christmas tree.
Oh, nice.
Check those out, Tommy. That is
Yeah.
some vintage handy talkies
I mean.
there. I think it's an AT2, an AT3, maybe an AT4. I can't read them from here,
Yeah.
but
Wow, look at the size of those things,
Yeah.
man.
yep,
That's when you had to be a real man to carry a handy talkie around
it is.
to work out.
So, congratulations,
Those are
Don. And we drew another winner for this month. And, well, I drew it right out. It came from Andy Biggs, KD8ZPX. He said, put my name in the hat for the next drawing. There's Andy's name right there. We put it in the hat. Not only that, why don't we have a drawing, Tommy?
Okay.
And who is
Looks like Andy Biggs is the winner.
KD8ZPX. So congratulations, Andy. Icon will be sending you Icon ball cap there.
Yep.
And a Ham Crew t-shirt.
So,
And thanks, Icon, for sponsoring Ham College for another year.
Absolutely.
Couldn't do it without you guys. We're talking about Christmas presents just a moment ago. Well, I did want to mention, for those out there who are studying for their technician exam, this is one right here that somebody ought to buy you. This is Gordon West Technician Class, a study guide. Pick that up. If somebody doesn't get it for you, pick it up yourself. This is really great material here. Not only will it help you pass the test, it'll go a little bit deeper and give you a little theory and some good practical examples.
Yeah, and there's some good reference material back in there too. After you get your license, there's some good stuff to go back and refer to.
This is without a doubt the best technician class study guide.
Oh yeah,
around.
no doubt. I recommend that one to anybody that asks about them.
And those of you studying for general or extra, he's got those available too. So check it out. Gordo, good friend of the show here. He really has.
Gordo's a good friend to ham radio, period.
Oh,
He's a ham radio icon, man.
He is. We've got some more questions, Tommy, and these are, well, it's a different subject. So why don't you kind of fill us in a little bit here and tell us what we're going to be talking about.
Okay, well, we're going to start branching off into antennas.
Okay.
So I got a little bit of a lesson on antennas here. It's a little overview about it before we get started.
Okay.
So basically, an antenna is a device designed to do two things. It captures radio frequency signals that are then converted to electrical signals by the receiver, and it takes electrical signals from the transmitter and converts them into radio frequency or RF signals. The second function is where the tuning comes into play, because an antenna has to radiate RF signals, something that's done best when the length of the antenna precisely matches the wavelength of the transmitted radio frequency. That's very important. The antenna precisely matches the wavelength. There are some formulas to easily calculate the wavelength, and we'll show those here at the end of the lesson. The first antennas were built in 1888 by German physicist Heinrich Hertz. We've talked about him quite a few times in the past. Anyway, he did those in his pioneering experiments to prove the existence of electromagnetic waves. Every antenna and every antenna feed line have a characteristic impedance or opposition to electrical current. In an ideal situation, the impedance of a line and antenna match perfectly, and 100% of the electrical energy sent to the antenna is converted to radio energy and radiated into the atmosphere. In a less than ideal case, when the impedances aren't perfectly matched, some of the electrical energy sent to the antenna won't be converted, but it'll be reflected back down the feed line. The energy reflected back down from the antenna causes standing waves of electrical energy in the feed line. The ratio of highest voltage on the feed line to the lowest is the standing wave ratio. In a perfectly matched system, the SWR, or standing wave ratio, is 1:1. The SWR can be tuned by using an SWR meter attached between the transmitter and the antenna feed line. Depending on the meter, you can either use a button to generate a signal, or you can key the microphone on the transceiver to generate a signal when you look at the SWR reading. In general, if the SWR never goes above 1.5 to 1, you're in good shape. If the SWR goes above 1.5 to 1, then watch the meter on different frequencies to see a trend developed. The SWR be greater on the higher frequencies or the lower. If the SWR is greater on the lower frequencies of the band, then try gradually lengthen the antenna by moving it in the base. If the SWR is greater on the higher frequencies, then try shortening the antenna.
And you want to talk about some formulas.
They need to be matched, the length, and that's a nice chart here that's got a formula to if you want to make a quarter wavelength antenna, the length is feet is 234 divided by the megahertz that you're trying to have the quarter wave antenna for.
All right, so your frequency in megahertz. Yeah, 234 divided by frequency in megahertz. Okay.
That'll give you the feet. Then, of course, if you want cut inches of wire, whatever, a more manageable unit of measure, then you could multiply by 12 to get the inches.
Yeah. And for a half wave, 468 divided by the frequency.
Yeah, and those, as you can see, those are just multiples.
We don't really need to remember all three of those, though. We only need to remember one of these.
Yeah.
So the one I choose to remember is the one for a half wave dipole, which is 468 divided by the frequency in megahertz. Because then I know if I'm thinking of a quarter wave antenna, well, I just cut that 468 in half.
Well, and the one I choose is a quarter wave because it's 234. Anybody can remember that sequence.
Yeah.
Then you can double it or quadruple it if you want to.
You can remember either one of those.
Yeah.
And you'll be able to figure out the other one easy enough.
Right.
So we'll be referring back to this. So down at the bottom there.
Yeah, if you want to figure out what meters, like, we've got 2 meters, 70 centimeters, so forth, you can divide 300 by the megahertz.
The frequency.
Or you can also do it backwards and divide it by the meters to get a rough estimate of the frequency
the wavelength
in megahertz.
Yeah, and that'll give you the wavelength in meters instead of in feet.
Uh-huh.
Let's get on into those questions then. And the first one here, I don't know who asked the last question. I think I did. So you can ask this one here.
Okay. Which of the following describe a simple dipole mounted so the conductor is parallel to the Earth's surface? A ground wave antenna.
B, a horizontally polarized antenna.
C, a rhombic antenna.
Or D, a vertically polarized antenna. All right, let me think about that again. Which of the following describes a simple dipole mounted so the conductor is parallel to the Earth's surface? All right, so this is my dipole right here. If it's parallel to the Earth's surface, then it's going to be like this. So it's horizontal. So it's not a ground wave antenna per se. B, a horizontally polarized antenna. That's what I'm going with. C, a rhombic antenna. No, it's not a rhombic. D, a vertically polarized antenna would be like this. It would be vertical, which is not parallel to the Earth's surface. So I'm going B, a horizontally polarized antenna, and everyone's agreeing with me over in the chat room.
Yep.
There we go. Horizontally polarized antenna. Simple enough on that one.
Yeah.
Let's see if we can make them a little bit tougher.
Okay.
So I'll throw one to you. What is the approximate length in inches of a 6-meter half wavelength wire dipole antenna?
Okay.
A, it's going to be 6 inches.
B, 50 inches.
C, 112.
Or D, 236 inches.
Okay, so cipher that out for us there, Tommy.
Okay, do we want to bring up the little formula back on the screen?
We can bring the formula back up on the screen.
So what we need to do is take 6 meters and figure out how many megahertz that is. So we'll go 300. Oops. Maybe we will. Divided by 6 meters. That's going to be about 50 megahertz.
Yep.
So now we want to go 468 divided by 50 megahertz. That's 9.36 feet times 12. 112.
Okay, that is
one
of the possible answers there.
Okay.
So let's see. 112.
C's my answer.
You're correct. C's your answer, and you're sticking to it.
That's my and I'm not even going to have to phone a friend or anything. So.
Yep. And it looks like they were saying C back in the chat
20
room.
minutes ago, back when we were working on it.
Yeah. Okay. Good to know. All right, let's move on to the next one here. Let's see, this is one for you to read.
Okay. What is the approximate length in inches of a quarter wavelength vertical antenna for 146 megahertz? A, 112.
B, 50.
C, 19.
D, 12.
I know this because I've built about
Yep.
5 or 6 of them.
Yeah, I think we all know that the answer for this one is going to be C, and that's what they're saying.
But let's go through the process,
Yep.
though.
But
So we want a quarter wavelength for 146 megahertz.
okay, so let's pull your calculator back up there and your formulas. So I'm going to say let's take 234 and divide it by 146. And that equals a big number there that's too small for me to see from here.
It's 1.60
All right.
to,
Then multiply that by 12 to get it to inches.
19.23 inches.
And we said it was 19 inches, so
We did.
yep,
So that's,
there we go.
the math doesn't lie. Even though we're not mathematicians. I'm a calculator
Yeah,
operator.
there you go. You can do this stuff if we can.
Yep. It's a living
All right.
proof.
The next one here is not going to require any ciphering.
Oh, man.
Yeah. How would you change a dipole antenna to make it resonant on a higher frequency? A, you would lengthen it.
B, insert coils in series with radiating wires.
C, you would shorten it.
Or D, add capacitive loading to the ends of the radiating wires. Now we discussed this a little earlier in the lesson.
Okay, how would you change
So
a
you
dipole antenna to make it resonant on a
Higher frequency.
Mhm.
Higher frequency is going to be a shorter antenna.
So you're saying that the length of the antenna is inversely proportional to the frequency.
Yes. That's exactly what I said. Didn't you hear me?
I just wanted to be sure. My hearing's not what it used to be.
So the answer is going to be C, shorten it.
Okay, that is correct. And everyone in the chat room was saying that was correct. Yeah, that's just something to remember there. The higher you go in frequency, the shorter your antennas get.
Mm-hmm. Yeah, and it's got to do with the wavelength.
Well, that's
The
the same.
length of the
yeah.
wavelength. So
Yep. Get a message from Ham Study, and then also we've got a little Easter egg here.
okay,
So,
and for
you know.
Christmas,
We always like those.
Easter eggs for Christmas.
Well,
Boy, we're
yeah.
hey, anything can happen around here.
Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stufflebean, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam.
I'm a spaceman. The moon and sun and all the stars are great big Tootsie Roll Pops. I'm a princess. Yes, my lord, it's a party tonight. We'll have Tootsie Roll Pops. All of the kids in the neighborhood say Tootsie Roll Pops are triple good. Triple good. And do you know why? Sure. Because 1, There's good tasting hard candy outside. And 2, there's a delicious center of Tootsie Roll inside. And 3, only Tootsie Roll Pops are such fun to eat. That's why they're triple good. And don't forget, Tootsie Roll Pops come in a party pack, too. 10 pops in assorted flavors. There's a game on the back that's lots of fun to do. All of the kids in the neighborhood say Tootsie Roll Pops are triple good. Triple good. You'll love Tootsie Roll Pops.
Hi, I'm Mike Wallace with a sensational shortening discovery for better baking and frying. It's Procter & Gamble's Golden Fluffo, the first all-new shortening in 40 years. It's rich. Its color is golden yellow. And what a pie it makes. Richer looking, better tasting, more appetizing. But let's hear what Mrs. Thelma Styra, Indiana State Fair baking champion, had to say about Fluffo.
I love Fluffo. It makes such a golden brown pie.
Oh, man, that's some apple pie.
Well, Mr. Wallace, that's a prettier pie than I ever baked with plain white shortening. And look how flaky it is. This yellow Fluffo is such a short shortening. Makes pie crust so rich.
Like cooking champions, get richer looking, better tasting, more appetizing results in everything you bake or fry. Get Golden Fluffo.
I've got a Swiss cream sandwich for you. Crisp golden cookies, and in between, an extra thick. It's my pick. Filling of cream. Dessert time. Tea time. Don't miss Swiss.
As the man around here, you can quote me on this. Yoo-hoo, it's Swiss cream sandwich for you.
And you too.
A truly different cream sandwich, Swiss cream sandwich, baked by Nabisco. The luscious, creamy fillings in a class by itself. No other like it. And these tempting vanilla cookies are so light, they melt in your mouth.
Yoo-hoo, it's Swiss cream sandwich for you.
And you too.
Swiss cream sandwich.
Attention. To help carry on our important work, I want you to join the Secret Squadron and wear this official badge and have this secret decoder. Following each week's adventure, I'll send an important secret message, and only Secret Squadron members who have decoders can decode them. Also, later I'll tell you the simple rules for joining the Secret Squadron, but you must promise to do as I do. Keep yourself healthy and mentally alert. And drink Ovaltine every day. It's the official drink of the Secret Squadron. We Secret Squadron members know chocolate-flavored Ovaltine helps give us what we need for rocket power. Yes, just as a rocket adds thrust during takeoff, Ovaltine can add the kind of nourishment so important for rocket power. We drink Ovaltine hot for breakfast. Good, too. And cold for lunch and between meal snacks. And hot again at bedtime to help keep us revved up with rocket power. Believe me, Ovaltine's got what it takes to help you be a leader in your gang. So drink instant Ovaltine every day.
I don't think I've ever had sweet ham flavored Ovaltine before.
No,
But I am a member of the Ham College Double Secret Probation Club.
You have the decoder ring.
I do have it.
Yeah.
Doesn't everybody?
Well, we've got a few more antenna questions to go here tonight before we're done, so let's get on back into those.
Which of the following is true regarding vertical antennas? A, the magnetic field is perpendicular to the Earth.
B, the electric field is perpendicular to the Earth.
C, the phase is inverted.
D, the phase is reversed. That'll make you think there for a minute, won't it?
Yeah.
Which of the following is true regarding vertical antennas? Well, you know, I know that the electrical field and the magnetic field will go two different directions.
Okay.
I say I know that. I believe that I know that. And I think perpendicular, vertical antenna, is perpendicular to the Earth. It's not parallel to it, so this would be, is that perpendicular?
Yeah, that's
All right, so I'm going to say that the electrical field coming off of here, it's going to be coming out the sides like that, so it's going to be perpendicular. No, that would be parallel with the Earth, wouldn't it? Anyway, I'm going to say the answer is the electrical field is perpendicular to the Earth. Well, that's not a really good explanation, is it? But I think it's one of those you need to remember.
You sure it's the electrical field?
Well,
You said the magnetic field goes one way, electrical field goes the other?
right. I know that it's not the phase is inverted or the phase is reversed. So it's either going to be the magnetic field or the electric field. I'm saying it's the electrical field is perpendicular to the Earth if your antenna is vertical.
Okay.
You buy that? Or you think it's the magnetic field? Or do you think it's neither one of those?
I'm not really sure. Electrical field. My first hunch was to say electrical field, but now I'm not totally sure.
Well, why don't you answer this one and give us a good chance to use the muscle?
I don't think so. I don't think so, George.
All right, I'm going to say it's the electric field.
Okay.
And that's correct. It is the electric field, and that's what everyone over in the chat room was saying, except we had one who said it was the magnetic field, and I think that's what you were going to say.
That's kind of what I was leaning towards.
Yeah.
But the more I think about it, now that I see the yellow mark on there,
that kind of just cleared it right up for you, didn't it?
It's so clear to me now.
Yep. But hey, that's going to be the only question like this you got on the exam. So when it comes up, just remember it was the electric field.
Yep.
There you go. All right, next question here. In which direction is the radiation strongest from a half-wave dipole in free space? A, it's equally in all directions.
B, off the ends of the antenna.
C, broadside to the antenna.
Or D, in the direction of the feed line. Okay, I'm going to scratch off D already. That doesn't make any sense.
A half-wave dipole.
Yeah, let me borrow your dipole here.
Okay. You're going to mount it
in all
horizontal.
directions. It's just impossible for it to be equally in all directions. If you look at this.
Yeah, that don't look the same from
Yeah,
this
there's a
end
lot
as
more
from the
surface
side.
area right here than there is there.
Mm-hmm.
Off the ends of the antenna. I don't think it's going to work like a shotgun. So I'm going with C, the broadside to the antenna. That's where the most surface area is. So that just makes the most sense. That it's going to be more directional.
Well, that's what they're saying in the chat room, and I think
here's
you're
your
right.
antenna back.
Yeah. There you go. Broadside of the antenna. This is the link that Mike sent to us.
Visual representation
of a dipole antenna. So it's showing really that the signal's all coming off of the broadsides of it, not off of the ends.
Right there. What type of antennas are the quad, Yagi, and dish? A, non-resonant antennas.
B, loop antennas.
C, directional antennas.
Or D, isotropic antennas. What type of antennas are quad, Yagi, and a dish? They're all resonant, so because antennas are generally resonant.
Mm-hmm.
Don't have to be, but the best ones are. So it's not they're not loop antennas. They're not isotropic. They're all directional antennas. You know, a quad is like multiple elements going in a direction. A Yagi, is sort of like a TV antenna, that style of antenna. And a dish, of course, we know that's directional.
That's super directional.
They're all directional antennas. Everyone's saying that over in the chat room, so...
Must be true then.
Must be true. There we go. Okay. Then I've got one for you, and I'm going to throw you for a loop here. What is a beam antenna? A, an antenna built from aluminum I-beams.
B, an omnidirectional antenna invented by Clarence Beam.
Is that Mr. Beans? No. C, an antenna that concentrates signals in one direction.
Or D, an antenna that reverses the phase of received signals. Okay, I'm going to go ahead and do just like I did the last ones. I'm going to scratch D right off the list right from the start.
Okay.
An antenna built from aluminum I-beams. Well, that seems like that would be a pretty heavy-duty antenna. I don't think that that's the answer. An omnidirectional antenna invented by Clarence Beam. And I don't know who this Clarence Beam fellow was, but whoever made up that question for the question pool may have been into something that had beam on the end of the name of it too, some Jim Beam or something. It's going to be C, an antenna that concentrates signals in one direction.
So you're saying it's beaming your signal in one direction?
Yeah, not like Clarence Beam.
Okay. There you go. That was correct. Everyone got it correct over there in the chat room as well. Jim Beam. They should have used that, invented by Jim Beam.
Because I think somebody had some of it.
Yeah, good to have. Okay, I think we got one final question tonight.
All right. Which of the following methods is used to locate sources of noise interference or jamming? A, echolocation.
B, Doppler radar.
C, radio direction finding.
Or D, phase locking.
Oh, cool.
Which of the following methods is used to locate sources of noise interference or jamming? Echolocation. I think that would be more like some type of radar. Doppler radar. No, I don't think that's going to locate noise or interference or someone jamming you. It's not going to be D, phase locking. It's going to be radio direction finding. You know, that's...
What about E? Somebody in here says an angry ham mob.
Yeah, I don't know.
I don't really recommend that source.
No.
Although it's probably happened before.
It's radio direction finding. That one's pretty straightforward.
Yeah. Yeah.
You'll see the term RDF sometimes. But
that's pretty interesting too. Do you remember the segment I did with the little MFJ dish for looking for interference or noise sources and things?
Yeah,
that was pretty cool stuff.
Noise.
I know you were the one. If you ever find somebody that's raking a wire across the file hooked to a 12-volt battery.
Yep. Especially if it's a 12-amp battery.
Yeah.
You can hunt them right down with that thing.
Yep. All you gotta do is look for the smoke.
Yeah, and the fire, and the file.
The flashes.
Yeah, the file with the little balls of metal on it. Yep. So I don't remember what episode Amateur Logic that was.
No, it's about a year ago.
Yep. Well, Tommy, that's got us to the end of the questions for tonight. I think we've got more antenna questions coming up.
That's
in the
good.
Next show.
That's good. Antennas. That's fun stuff.
Yeah, we appreciate everyone being here with us tonight. Another fun show. We won't do this again till next year.
Yep. We'll be here before you know it, though. You know, time flies.
It will be here.
So here, catch this.
It's not charged up. Yeah, I don't know what I'm going to do for New Year's yet. I'll have to come up with something, though.
Yep. Well, Merry Christmas to everybody.
Merry Christmas.
We'll see you next year.
Happy Hanukkah. Happy New Year.
All those things.
Yep.
Whatever you celebrate, and be careful and enjoy.
Insert your holiday here.
Yeah.
We'll see you next time.
73.
We never did talk about why that meter was so blue there, though.
No, we didn't.
We just showed it and quickly moved on.
Yeah. Well, seems like we should maybe do that again.
Quickly move on. Yeah. Trifle thou not with radioactive tubes or substances. You can see where this one's going. Strike B there. Ensure that the circuit is not powered. Well, no, don't strike it. Check that, because I want to be sure that it's not powered. What is the characteristic impedance? What is the characteristic?
Well, okay.
Let me try it again.
Want me to read my own?
This one comes from Don, KB2YSI. And he said, George, put my name in the hat. It came from Andy. And I screwed that up real good.
Yeah.